Electrical inspectors commonly require UL approval for sensors used in building management systems. The National Electrical Code, specifically Article 110.2, mandates that electrical equipment and materials be approved for the intended use. Similarly, NEC Article 90.7 requires equipment to be listed, meaning approved, by a qualified testing laboratory. In addition, the National Fire Alarm and Signaling Code, NFPA 72, also requires smoke and fire detectors to be UL listed. UL 217 is the standard for temperature-sensitive elements for use in air duct systems, while UL 508 is the standard for industrial control equipment. Some sensors, such as custom-designed sensors or sensors used in research or testing applications, may not have UL approval. If a suitable UL-approved sensor is not available, the inspector may allow the use of a non-UL-approved sensor with specific conditions, such as the sensor is installed in a non-hazardous location, the sensor is protected from physical damage and environmental hazards, and the sensor is tested and verified to meet equivalent safety standards. Electrical inspectors may require UL approval for sensors in building management systems as a safety measure to ensure that the sensors are designed and tested to meet industry safety standards, are compatible with the building management system and provide accurate readings, and do not pose a fire or electrical hazard when installed in ductwork or other critical areas. If you encounter an inspector requiring UL approval for a sensor where a suitable UL-approved sensor is not available, you can firstly contact the inspector and provide documentation to support the claim that a suitable UL-approved sensor is not available for the specific application. Secondly, suggest alternative measures to ensure the safety and reliability of the non-UL-approved sensor. Thirdly, if necessary, seek clarification from the local authority having jurisdiction or consult with a qualified electrical engineer. Article 110.2 of the National Electrical Code, NEC, addresses the approval of equipment. It mandates that all electrical equipment used must be approved. Approval, in this context, means that the equipment has been evaluated by a recognized testing laboratory and found to be safe and suitable for its intended purpose. This approval is typically indicated by a listing mark such as UL, ETL, or CSA. The rationale behind Article 110.2 is to ensure electrical safety and prevent hazards like fires or electrical shocks. Using approved equipment minimizes the risk of equipment failure and ensures that it meets established safety standards. Article 90.7 of the NEC further elaborates on the requirements for equipment approval. It specifies that equipment must be listed by a qualified testing laboratory. Listing involves a thorough evaluation process by a recognized testing organization, which includes testing the equipment to ensure it meets specific safety standards. The listing mark serves as evidence that the equipment has undergone this evaluation and complies with the relevant safety requirements. The purpose of Article 90.7 is to provide a clear and reliable mechanism for verifying the safety and suitability of electrical equipment. By requiring listing from a qualified testing laboratory, the NEC ensures that equipment has been independently assessed and meets established safety criteria. NFPA 72, the National Fire Alarm and Signaling Code, has specific requirements for smoke and fire detectors. These detectors must be UL listed, meaning they have been evaluated and certified by underwriters laboratories, all to meet stringent performance and safety standards. The requirements in NFPA 72 are designed to ensure that fire detection systems are reliable and effective in providing early warning of fire hazards. UL listing for smoke and fire detectors involves rigorous testing to verify their sensitivity, response time, and ability to operate reliably in various environmental conditions. The UL 217 standard specifically addresses temperature-sensitive elements used in air duct systems. This standard outlines the requirements for the design, construction, and performance of temperature sensors used in heating, ventilation, and air conditioning (HVAC) systems. UL 217 aims to ensure that these sensors are safe, reliable, and capable of accurately detecting temperature changes within air ducts. The standard covers various aspects of sensor design, including materials, electrical components, and environmental protection. It also includes performance testing to verify the sensor's accuracy, stability, and response time. UL 508 is the standard for industrial control equipment. It covers a broad range of electrical and electronic components and systems used in industrial applications. This standard sets the requirements for the design, construction, and performance of industrial control equipment, including motor controllers, programmable logic controllers, PLCs, and other control devices. UL 508 aims to ensure that industrial control equipment is safe, reliable, and capable of operating in demanding industrial environments. The standard addresses various aspects of equipment design, including electrical safety, mechanical construction, and environmental protection. It also includes performance testing to verify the equipment's functionality and durability. There are exceptions to the UL approval requirements for sensors in building management systems. These exceptions typically apply to custom-designed sensors or sensors used in research or testing applications where UL-listed options may not be available. In cases where a suitable UL-approved sensor is not available, an electrical inspector may allow the use of a non-UL approved sensor under specific conditions. These conditions are intended to ensure the safety and reliability of the installation despite the absence of UL listing. Firstly, the sensor must be installed in a non-hazardous location. This means the sensor should be located in an area where there is no risk of explosion, fire, or other hazards. Secondly, the sensor must be protected from physical damage and environmental hazards. This may involve installing the sensor in an enclosure or providing other forms of protection to prevent damage from moisture, dust, or other environmental factors. Thirdly, the sensor must be tested and verified to meet equivalent safety standards. This may involve conducting tests to ensure that the sensor meets the performance and safety requirements of relevant UL standards or other recognized standards. Electrical inspectors require UL approval for sensors in building management systems to ensure that the sensors meet industry safety standards. UL listing provides assurance that the sensors have been tested and evaluated by a recognized testing laboratory and found to comply with established safety requirements. This helps to minimize the risk of electrical hazards and ensure the safety of building occupants. UL approval also ensures that the sensors are compatible with the building management system and provide accurate readings. Sensors that have not been properly tested and evaluated may not provide reliable data, which can affect the performance of the building management system and potentially lead to energy waste or other operational problems. Additionally, UL approval helps to ensure that the sensors do not pose a fire or electrical hazard when installed in ductwork or other critical areas. Sensors that are not properly designed and constructed may overheat or malfunction, potentially causing a fire or electrical shock. When dealing with electrical inspectors who require UL approval for sensors, firstly, it is important to contact the inspector and provide documentation to support your claim that a suitable UL-approved sensor is not available for the specific application. This documentation may include product specifications, technical data sheets, and other information that demonstrates the sensor's suitability for the intended use. Secondly, suggest alternative measures to ensure the safety and reliability of the non-UL approved sensor. This may involve proposing additional testing, inspections, or other safeguards to address the inspector's concerns. Thirdly, if necessary, seek clarification from the local authority having jurisdiction, or consult with a qualified electrical engineer. The AHJ is the governing body responsible for enforcing the electrical codes and regulations in your area. An electrical engineer can provide expert guidance on electrical safety and compliance issues. NEC Article 110.3 B provides specific guidance on how to evaluate equipment. This section states that listed or labeled equipment shall be installed and used in accordance with any instructions included in a listing or labeling. If the equipment is not listed or labeled, it must be suitable for the intended use. The suitability of equipment can be determined by several factors, including the following. Firstly, testing by a qualified testing laboratory. Secondly, inspection by the authority having jurisdiction. Thirdly, manufacturer's documentation. Fourthly, field experience. When evaluating equipment, It is important to consider all of these factors to ensure that the equipment is safe and suitable for the intended use. If the equipment is listed or labeled, the installation and use instructions must be followed carefully. If the equipment is not listed or labeled, the suitability of the equipment must be determined based on the factors listed above. It is important to document the evaluation process and to keep records of any testing, inspections, or other assessments that are performed. This documentation can be used to demonstrate compliance with the NEC and to provide evidence of the equipment's suitability for the intended use. In the context of building management systems, BMS, sensors play a crucial role in monitoring and controlling various environmental parameters such as temperature, humidity, and air quality. These sensors provide data that is used to optimize building performance, improve energy efficiency, and ensure occupant comfort and safety. The installation of sensors in ductwork presents unique challenges due to the confined spaces, potential for exposure to environmental contaminants, and the need to maintain proper airflow. Therefore, it is essential to carefully consider the sensor's design, construction, and installation methods to ensure its reliability and accuracy. When selecting sensors for ductwork applications, it is important to choose sensors that are specifically designed for this purpose. These sensors should be able to withstand the harsh environmental conditions found in ductwork, such as temperature extremes, humidity, and dust. They should also be designed to minimize any disruption to airflow. In addition to selecting appropriate sensors, it is also important to follow proper installation practices. This includes ensuring that the sensors are properly mounted, wired, and calibrated. It is also important to protect the sensors from physical damage and environmental hazards. The electrical inspector's role is to ensure that electrical installations comply with the NEC and other applicable codes and standards. This includes verifying that all electrical equipment is approved for its intended use and that it is installed in accordance with the manufacturer's instructions. When an electrical inspector identifies a potential issue, such as a non-UL listed sensor, it is important to work with the inspector to address their concerns. This may involve providing documentation to support the use of the non-UL listed sensor, proposing alternative safety measures, or consulting with a qualified electrical engineer. It is also important to understand the inspector's perspective. Electrical inspectors are responsible for ensuring the safety of electrical installations, and they must adhere to the requirements of the NEC and other applicable codes and standards. Their primary concern is to protect people and property from electrical hazards. Therefore, it is important to be respectful of the inspector's position and to work collaboratively to find solutions that meet their requirements while also ensuring the functionality and performance of the building management system. In some cases, it may be necessary to seek clarification from the authority having jurisdiction (OJ). The AHJ is the governing body responsible for enforcing electrical codes and regulations in your area. The AHJ can provide guidance on the interpretation of the NEC and other applicable codes and standards. They can also provide waivers or exceptions to the code requirements in certain circumstances. If you are unable to resolve a dispute with an electrical inspector, you can appeal their decision to the AHJ. The AHJ will review the situation and make a final determination. When consulting with a qualified electrical engineer, it is important to provide them with all of the relevant information about the sensor installation, including the sensor's specifications, the intended use of the sensor, and the electrical inspector's concerns. The electrical engineer can then evaluate the installation and provide recommendations for addressing the inspector's concerns. This may involve proposing alternative safety measures such as additional testing or inspections, or providing documentation to support the use of the non-UL listed sensor. The electrical engineer can also help to negotiate with the electrical inspector and the AHJ to find a resolution that meets everyone's requirements. In conclusion, understanding the NEC requirements for equipment approval, including UL listing, is crucial for ensuring the safety and compliance of building management systems. While UL listing is generally required for electrical equipment, exceptions may be granted under certain circumstances, such as when a suitable UL listed sensor is not available. In these cases, it is important to work with the electrical inspector, provide documentation to support the use of the non-UL listed sensor, and propose alternative safety measures. If necessary, seek clarification from the AHA or consult with a qualified electrical engineer. By following these steps, you can ensure the safety and reliability of your building management system while also complying with the NEC and other applicable codes and standards.